It is well known that when a ship is sailing in following and quartering seas, the ship's motions will be augmented and the possibility of it capsizing will be increased when compared to sailing in against or beam seas. It is therefore important to possess more detailed knowledge about these risks for safer navigation in following and quartering seas. The ship handling techniques that we are to study here are also available in the International Maritime Organization Circular Guidance to the Masters for Avoiding Dangerous Situations in Following and Quartering Seas. According to the guidance, risks in following and quartering seas may arise when a ship is sailing in the same direction and at the same speed as the problem waves. Let's take a close look at the effects of these seas upon a ship's stability. The situations that should be most carefully monitored in following and quartering seas when the ship is traveling in the same direction and at the same speed as the problem waves are the encounter wave grouping phenomena, parametric rolling, the reduction of stability, and the broaching to phenomenon. These four serial phenomena are the characteristics of encounter wave grouping phenomena. First, let's take a look at encounter wave grouping phenomena. Ocean waves are an integration of irregular waves comprising those of diverse lengths, heights, and directions. Encounter wave grouping phenomena occur when a ship is sailing in rough seas that involve irregular waves with sudden serial high waves attacking the ship regularly from aft. This means that when a ship is sailing in the same direction and at the same speed as the high wave group, the ship might be constantly hit by severe serial high waves. This is called the dangerous encounter wave grouping phenomenon. To avoid dangerous encounter wave grouping phenomena, it is essential to eliminate the speed conditions that cause such phenomena. As suggested by many experimental results, the most probable condition a ship might be caught in dangerous encounter wave grouping phenomena can be expressed by the formulae shown here. A combination of encounter angles of the ship to the wave coming from the aft, the ship's speed, and the wave period. According to the IMO's ship handling guidance, a dangerous zone is defined as VT being 1.5 as the norm, with a range between 0.8 and 2.0. If your ship is in the dangerous zone as defined by a combination of the ship's speed and the encounter wave period, countermeasures are imperative. Therefore, you must remove the ship from this danger zone, allowing the waves to pass by without doing any harm and avoiding the dangerous encounter wave grouping phenomena by reducing the ship's speed or by altering course. Next, we'll take a look at parametric rolling phenomena, one of the operational parameters endangering a ship in following and quartering seas. When a ship proceeds through regular longitudinal waves, the ship rolls repeatedly, for instance to the starboard side on the first crest and to the port side on the following trough. However, when parametric rolling occurs, a ship rolls to the starboard side on the first crest and to the port side on the following crest, which means that one rolling cycle is completed for every 2 wave cycles. Consequently, the amplitude of the ship's roll is gradually magnified. To understand this more easily, let us compare ordinary rolling and parametric rolling. When you look at these motions more closely, you will notice that the ship rolls only once for every 2 cycles of passing waves, while the ship pitches once synchronous to the cycle of passing waves. This type of rolling is magnified when the encounter wave period reaches half of the ship's natural rolling period. This means that as GM decreases, the probability of parametric rolling increases. In order to avoid parametric rolling, it is necessary to adjust the encounter wave period so that it does not coincide with 1/2 of the natural rolling period of the ship. In other words, when the ship rolls once while pitching twice, you should reduce the ship's speed as much as possible to maintain her course upon judging the ship is subject to parametric rolling. Next, we will look at the dangers resulting from a reduction in stability. While sailing in following and quartering seas, great attention has to be paid to the reduction of stability. The degree of stability is determined generally by the area of the waterplane as previously shown in the chart. For instance, if a ship rides on a crest equal in length to the ship's length at midships, stability is reduced as the water planes at her bow and stern decrease due to the lower water lines at both ends. On the other hand, when a trough of the same wave passes the midships, stability is increased as the water planes at her bow and stern increase due to higher water lines. Even if a ship is in a situation with reduced stability, the time span the ship might endure this will be shorter when sailing in counterseas. Conversely, the possibility of risk is increased in following and quartering seas, as the time span is greatly increased. Now let's see how to avoid the risks stemming from a reduction in stability. The diagram shows instances of the model ship capsizing in tank experiments. You can see capsizing occurred around 1.5 when dangerous encounter wave grouping phenomena are more frequent. To avoid the risk of capsizing due to a reduction of stability, you need to have your ship sail clear of this dangerous zone to minimize the chances of riding on the crests of waves for a prolonged period. For this purpose, you also need to reduce the ship's speed or alter course, or do both to change the encounter wave angle. Broaching to is also one of the dangerous phenomena which can occur when a ship is sailing in following and quartering seas. Let's take a look at this phenomenon. Broaching to is a very dangerous phenomenon, often resulting from surf riding, in which a ship loses steerage upon being accelerated at the downslope of a wave in following and quartering seas. This is an extremely dangerous phenomenon, as the ship will lose steerage and turn abruptly with great centrifugal inertia, exposing her broadside to beam seas, often resulting in instantaneous capsizing. The broaching to phenomenon is considered to be caused by this surf riding. To avoid surf riding, you should know the critical ship speed that causes this phenomenon. The critical speed that causes surf riding is considered to be 1.8 multiplied by root L. Therefore, you should reduce the ship's speed to less than 1.8 multiplied by root L. In addition, even before reaching the surf riding condition, to avoid large surgings likely to induce the broaching to condition, it's necessary to reduce the ship's speed to less than 1.4 multiplied by root L. The formulae shown here are also cited as the criteria for avoiding broaching to in the guidance adopted by the IMO. However, when a ship is sailing in shallow waters, a surf riding phenomenon can be caused even when a ship is sailing at a comparatively low speed. This should be borne in mind, in particular by seafarers operating high-speed pleasure boats and fishing vessels. To prevent encounter wave grouping phenomena, it's necessary to take care so that any combination of important factors, such as encounter wave angle, ship speed and wave period, do not fall in the danger zone. To prevent parametric rolling, it's necessary to take care so that the encounter wave period to the ship's natural rolling period ratio does not fall to half. To prevent a reduction of stability, it's necessary to avoid the ship riding on the crest of a wave for an extended period by reducing the ship's speed or by altering course. To prevent surf riding and broaching to, it's necessary to be aware of the critical speed leading to surf riding conditions. In addition, take special precautions to prevent these phenomena when a ship is sailing in shallow waters. For seafarers operating pleasure boats, high-speed fishing vessels, small and medium-sized ships, this should be particularly borne in mind. We hope this video helps to promote safe ship operations by reminding you to observe the basic ship handling requirements and by providing you with sufficient knowledge on the dangers of sailing in following and quartering seas.